In lesson 61, we are looking at more of our chemical mixture problems. We're going to do type B today. So what we have done so far, type A, was we took two mixtures and we combined them together. And so we had one amount plus another amount was the final amount. Volume is just the amount. How much do you have? No percents at all in that equation. And then we had one, P1, V1, plus P2, V2 was PF, VF. The first percent times the first amount plus the second percent times the second amount was the final percent times the final amount. And we'll also do a slight variation on that model with some of our examples today, almost the same as what we've been doing, but a slight change. The big difference is the other thing we could do, instead of putting two things together, we could evaporate something off or distill something out of it or remove in some way. So if you're doing your science experiment, you start out with something. If you heat it, the steam boils off and you end up with a smaller amount. You at least know that, even if you haven't done that in a science class. You leave a boiling pot of water on the stove too long, or soup or whatever, and it boils and it eventually all dries up. The amount goes away as the water boils off. So in this one, in type 2, the difference is going to be that we have an initial amount and we take something away from it. Usually we boil off water or something like that to get the final amount. And we're still going to have the first percent times the first volume, but now minus the second percent times the second volume to be the final percent times the final volume. So type A is adding them together. Type 2 is taking something away from it. So let's do an example of type 2. So we've got a saltwater solution. Brine just means salt or saline. And we are going to start boiling that. What's going to boil off? The steam is going to be all water. The salt isn't going to boil out of there. The salt stays in there. It's just the water that boils away. And then we're going to end up with a lesser amount, and it's going to be 40% brine. I'm going to go through and work this one two ways, and you can think about which way seems easier. First, we're going to do the percentage of water. Now, the V1 minus V2 equals VF will be the same either way, because we are going to take our first solution minus our second to get our final amount. Okay, the only amount that I see in there is 400 gallons. Is that my starting amount? Is that how much I boil away, or is that how much I end up with? Use your English language context clues, just reading it. Is the 400 what you start with, what you take away, or what you end up with? Jonas. It's what you start with. You're evaporating it away from. So you're starting with the 400 and then evaporating some away and ending up with some final amount. Now, if I do these with percentages of water, I am boiling away water, and V2 is the one I need to end up with because it says how much water, so how much V2? Water is what percent water? It's 100% water. So I'm going to put my 100% times the V2. If I have my 400 gallons and they are 15% salt, do I use the 15 when I'm using 100% water? So what percent water would the 15% salt solution be? So this one's going to be 85% water. So I'm going to have the 85 times the 400. And I want to end up with 40% salt. So what percent water? So then I'm going to have 60 times the VF. I need to do a substitution, And I know that VF is 400 minus V2. So I'm going to change this VF right here to 400 minus V2. So give me a thumbs up, thumbs down. Does that setup make sense to you so far? Okay, I could keep going and solve that. I'm going to do my other setup, and then I'm going to decide which one seems easier and pick one of these two ways to solve it. So if I do it with the percent salt, I still have V1 minus V2 is VF. So I still have 400 that I start with, minus V2 is VF. What changes is this next equation, I'm going to use the salt percents. So I start off with 15% when I have the 400 gallons. Water is what percent salt? So I get to do a 0 V2 right here. And then my VF is going to be 40% salt. And I know that my VF, from what I just said, is 400 minus V2. So let me have a vote. This one on the right is going to be 15 times 400 equals 40 times 400 minus V2, because that 0 stuff is going to go away. How many would like to solve it the blue way? Raise your hands. How many would rather solve it the green way, that it looks easier? Majority rules will solve it the green way. So what I have now is 15 times 400 is 40 times 400 minus 40 times V2. So I could say that my minus 40 V2 over here is 15 times 400 minus 40 times 400. And I could punch those in my calculator if I wanted to and write those little pieces down. Or I could just I could factor out the 400. It's a greatest common factor. And I could say I have 400 times 15 minus 40 equals my minus 40 over V2. And you could go ahead and be punching that in your calculator right now if you wanted to. Or I think I'll go ahead and write down I'm going to divide by the minus 40. So I know I'm going to have V2 over here on the right. I know if I take the 400 over 40, that gives me a 10, but I've got to remember this minus sign in there. What's 15 minus 40? So I have 10 times negative 25 over a minus 1. Can you tell me what that equals without using your calculator? Positive 250. And then to finish my labeling, these are gallons, and this is V2 was the water that I wanted to find. So gallons of water. Question from anybody on that one? Does that type B problem make sense? It's just like what we were doing before, except we have a minus sign in both of our equations. And we still have to make sure we're consistent with our percents all the way through, either all salt or all water or whatever the problem might have. Okay, next one is actually a review of a type 1 problem, but one slight difference from what we've usually been doing. So they have 900 pounds of milk that was 2% butterfat, and now they are going to add butterfat as they are working this problem. So type A with a plus sign, V1 plus V2 is VF. No percents in that equation. In the problem, the only amount I see is 900 pounds. Is that V1, V2, or VF? It's what? This is what they start with, right? And then they are going to add this to get a final. So that 900 is our V1. And this is what's a little bit different. The problems you've had so far, you've known the final amount, you've known VF. This one, the amount they tell you is not VF. That's the only slight little difference on this. Okay, I have said let's use this one on our percent equation with percents butterfat. So we know the first one was 2%, so 2% times the first amount plus what percent butterfat is butterfat? It's 100. We're going to add pure fat on this. So 100 times the V2. And then we want to end up with 8% times the final amount. So what's a little bit different now is this substitution is going to be over here. We just did that on the type B problem, but your type A practice problems to now have mostly been, you know what VF is. So now this just becomes 1800 plus 100 V2 is 8 times 900 plus V2. So that is 7200 plus 8 V2, I think. Check my work on that. Does this look right so far? And so if I subtract my 8 V2 on both sides, do I have 92 V2 here on the left? Thumbs up, thumbs down, check my work. So I've seen some heads nod. If I subtract 1800 on both sides, I need to be a little more careful here. 0, 0, I need to borrow. 12 minus 8 is 4, and 6 minus 1 is 5, 5400. And I am going to let you guys help me out with the calculators here. I am going to divide both sides by 92. So what is this 5400 over 92? And please put a decimal in there somewhere for me. Let's get a decimal answer that makes sense so I know how much I am talking about with that. Alex, what'd you get? Others 58.696. Give me a thumbs up or thumbs down. And we need to label it. Units for this problem were pounds, and V2 was the butter fat that we are adding. So I need to label that as pounds LB of butter fat. So are we good with that one? Okay, one last example, and then we'll do some work on problems. Okay, we start off with a 40% alcohol solution. Actually, no, we're going to add a 40% alcohol solution to 100 milliliters of a 20% alcohol solution to get a solution that's 35% alcohol. So we're adding two things together in this one. So we know it's the first kind of problem. It's a V1 plus V2 is the final amount. Right, so I am going to add the 40% to 100 milliliters to get the final percent. Does that make sense for our first equation? And it really doesn't matter the order on V1 and V2. If you wanted to switch those, that's okay because you're adding. Subtracting is another story, but adding the order doesn't matter. So I start off with 100 milliliters. I add something to get a final. Now I need to do my percents, and 40% alcohol, 20% alcohol, 35% alcohol, they're all consistent. So I'm going to use 20% That was the 100 milliliters. 100 milliliters of a 20%. So the 100 has to be multiplied by the 20%. Then what I am adding is a 40%, and V2 is what I need to find because V2 is my 40% solution. And then I want my final solution to be 35%. But instead of writing VF, I'm going to substitute 100 plus V2 in there. Is everybody okay with that? Okay, can you solve that equation for V2? Go ahead and try to do that on your own without looking up. I'll start it here on the board in a moment. If you get stuck, then you can certainly look up here. But does everybody see how that's just one equation with one variable? So distribute, combine like terms, and figure out what V2 needs to be. So what'd you guys get? Did I do it right? 300 milliliters? Anybody with questions? All right, we will stop there and get busy with practice.